When do I think we can go to Mars? I think 5 years from now.
Ever wonder what life would be like on another planet? Leaving Earth to find new homes in space is an old dream of humanity. Mars is seen as a possible site for colonization. What if we think bigger? Venus, one of the most hostile and deadly places in the solar system. So what if humanity transforms two planets of dust and rocks into a thriving human colony at the same time? Venus orbits close to the inner edge of the Sun's hertz at an average distance of about 67.69 million mi, or 0.728 times the distance between the Earth and the Sun. Venus receives twice as much solar radiation as Earth at this distance, contributing to its extremely hot atmosphere. Venus is the hottest planet in the solar system, with a mean temperature of 867 degrees Fahrenheit, hot enough to melt lead. The atmosphere is composed mainly of carbon dioxide, the remainder being nitrogen and trace gases. The surface atmospheric pressure is estimated at 93 bar, roughly 92 times the air pressure on Earth at sea level. Its closer proximity to the Sun means it has a shorter year, taking 224.7 days to complete an orbit of the Sun. The planet rotates in the opposite direction of most of the solar planets and very slowly to boot, taking over 243 days to complete a single rotation on its axis. How about the Mars? At the other end of the hertz is Mars. The red planet orbits our Sun at an average distance of about 155.72 million mi, or 1.5 times the distance between the Earth and the Sun. Mars receives about half as much solar radiation at this distance as Earth. Its wider orbit results in an orbital period of 686.98 days, making a year on Mars almost twice as long as one on Earth. On the other hand, a day on Mars lasts about the same as a day on Earth minus 24 hours, 37 minutes, and 22.7 seconds. The atmosphere is incredibly thin, with a surface pressure of 6.52 millibars, or roughly 0.6% of Earth's at sea level. And like Venus, it's largely composed of carbon dioxide, with trace amounts of argon, nitrogen, oxygen, and water vapor. In short, Venus is too hot, its atmosphere is too thick and toxic, and it rotates too slowly. Mars is too cold, the atmosphere is too thin and toxic, and it rotates just fine for our purposes, anyway. Therefore, making these planets more accommodating to Earth organisms requires specific and opposing strategies. What is that strategy? As we explored, terraforming Mars also comes down to 3 steps, including melting the ice caps, thicken the atmosphere, triggering a greenhouse effect, and introducing a magnetic field. Thermal boreholes drilled into the Mars surface will release heat and carbon dioxide that will thicken the atmosphere further and increase surface temperatures. However, these results suggest that there is not enough CO2 remaining on Mars to provide significant greenhouse warming where the gas is to be placed into the atmosphere. Venus, on the other hand, has far too much carbon dioxide. What's more, the aforementioned terraforming strategy leads to byproducts, dry ice and graphite, that must be dealt with. If these were transported to Mars, they could help make up the CO2 deficit. Dry ice could be transported to Mars and dropped into the atmosphere, where it would sublimate before reaching the ground, gradually thickening it. In either case, the main issue is that of transport. A possible solution is to leverage the long-range scenario. After bombarding Venus' atmosphere with hydrogen, automated facilities could be deployed to the surface to collect and store the graphite. Meanwhile, other facilities would collect rainwater and convert it into liquid hydrogen and oxygen. This would allow reusable rockets to land on the surface, refuel, be loaded with graphite, and take off for Mars. Alternately, Some of this graphite and/or dry ice could be used to create graphene ribbons, a supermaterial with incredible tensile strength. These could be connected to a station in geostationary orbit, making a space elevator to lift megatons of graphite or dry ice from the surface to orbit. Furthermore, the orbital shields and mirrors could be assembled using carbon supermaterials. These could be harvested directly from Venus' atmosphere by floating platforms stationed 31 miles above the surface, where the atmosphere is warm, and the atmospheric pressure is comparable to Earth at sea level. This way, the same mirrors that help warm Mars and cool Venus could be assembled from the same source. Then, how will the two new houses be greened? Finally, severe ecological engineering can begin once Mars and Venus have been warmed and cooled. The first to go would be simple single-celled life forms, lichens, moss, and other photosynthetic organisms. These would gradually convert atmospheric CO2 into oxygen gas and organic nutrients. As water accumulates on the surface, algae, seagrasses, and kelp would help balance the acidity of the rivers, lakes, and oceans. Grass, plants, and trees would follow, stabilizing the soil and creating a nitrogen and water cycle. As these organisms die and break down in the soil, they further enrich it with organic nutrients, paving the way for insects, nematodes, and other terrestrial and marine invertebrates. The final step would be introducing complex life forms like avians, reptiles, amphibians, and mammals to both worlds. This would complete the carbon cycle and would maintain habitability over time. These advancements would allow humanity to become an interplanetary species. But to truly expand and plant the seed of human civilization in extraterrestrial soil, we must ensure that we bring Earth's ecosystem and cycles with us, in one form or another. In the short term, bioregenerative life support systems can accomplish this. But in the long run, the most effective way to support life is to recreate Earth-like conditions on other planets. And while it may be a far-off prospect, terraforming could be accomplished with the right technology, know-how, and dedication. Considering the immense benefits, it is something we may find ourselves doing before long. What do you think about terraforming Venus and Mars? If you could, which house would you choose to live in? Give your comment below.